So we recently defined probability as the number of times a particular outcome can occur given all the possible other outcomes that can occur. So we're going to define this a little bit more officially using this probability formula, where P of x refers to probability, and we're going to say that P of x, or the probability of outcome x occurring, is the number of times that x can occur divided by the number of times any outcome can occur. All right, so again, what this means is that when we're looking at probability, we're considering the number of times our outcome of interest, which we're calling x, can happen, and we're dividing that by the number of times any outcome can happen. And so what I'm going to do here is I'm going to give you guys an example of calculating probabilities. Now, in a typical semester, we do this with M&Ms, and we look at the color of M&Ms, and I bring everybody M&Ms, and it's wonderful, and it's the best day of the semester. Now, of course, I'm not bringing you M&Ms, and not only am I not bringing you M&Ms, but I also haven't gone grocery shopping in a while, so I don't have any M&Ms either. So instead, we're going to use this pot full of crayons that I have lying around because I have a 3-year-old. So what we're going to be doing here is we're going to be looking at the color of these crayons. And specifically, we want to know the probability of drawing different colors of crayons here. And so to determine that, we're going to use this probability formula to come up with the probability of drawing each of the different colors of crayons that we have. So the first thing that I'm going to do here is I'm going to put them in order. Not in order, but just organize them by color. I guess I might as well make a rainbow while I'm at it. I'm organizing them by color so that we can see how many we have of each of the different colors. All right, there we go. That's much more visually pleasing. Okay, so we're going to start with the probability of choosing a red crayon. And so to find the probability of choosing a red crayon, we want to know the number of times we could get a red crayon out of the number of times that we could get any color of crayon. So the first part is easy. We have one red crayon in here, or red-violet crayon, I guess, and that means that we have one chance to get a red crayon. So the numerator of our equation, or the number of times that x can occur, is 1. The denominator of our equation, or the number of times that any outcome can occur, is given by the number of crayons we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 crayons. That means that our probability of getting red is going to be given to us by 1 over 12. If you do this math, it comes out to 0.083, or 8.3%. So we'd say that if we jumbled up all these crayons, put them back in the crayon pot, we would have a probability of 8.3% of grabbing a red crayon. And so I'm going to go through a little bit more quickly now and write out the probabilities for each of these. So our next color is orange. What's the probability of getting an orange crayon? Well, what we want to do is count up the number of times orange can occur, so orange is our outcome, and divide it by the total number of possible outcomes that we have. So here you can see we have 2 oranges, 1, 2. So we're going to put 2 in the numerator of our equation. And we still have the same number of crayons. So we still have 12 crayons. That means there's 12 possible outcomes. So we'll put 12 as the denominator again. All right, so now we're looking at 2 out of 12 as our equation here. And that means we have a probability of 0.166, or, sorry, 0.167, I think, or 16.7%. So we'd say there is a 16.7% chance of picking an orange crayon. All right, yellow, And now we're going to do the same thing for each of these. So we want to see how many yellow crayons we have. That's 2 again. And we still have 12 crayons total. So that means we have 2 chances to get a yellow crayon out of our 12 chances to get any color crayon. So 2 out of 12 is the same number. So here we've got 0.167 or 16.7%. So you have the same probability of grabbing an orange crayon as you do of grabbing a yellow crayon. And that should seem intuitive to you because you can look here and you can see we have the same amount of orange as we do of yellow. Alright, now we've got our green crayons. And I'm going to treat all shades of green as the same color here. So what that means is that we have 3 different green crayons, this one, and this one, or 3 chances to get green out of 12 chances to get any crayon. And if we do 3 out of 12, that gives us a probability of 0.25 or 25%. Alright, moving along, we've got our blue crayons now. Here we have 2 blue crayons again, so my camera's lighting's not great here, but we've got, so you can see a little bit more of the wrapper. We have 2 blue crayons, so that's going to be 2 blue crayons out of 12 crayons again, and that's going to also be 0.167 or 16.7%. And then finally, we also have 2 purple crayons. So that's 2 out of 12. Again, 2 purple crayons, so 2 chances to get purple out of 12 crayons total. Alright, so we've now calculated probabilities. And I think the most important thing that I want to show you here is not only how to calculate them, but also how the numbers match up to what you can actually see going on here. And it should make sense to you, and it should be intuitive given what you know about probability just from, reading the weather and existing in the world, that the bigger your number, the more represented that outcome is among your possible outcomes. So our most likely outcome here is green, and you should be able to see that pretty easily by seeing that we have more green crayons than anything else. Our least likely outcome is red at 8.3%, and what you can see here is that we only have 1 red crayon, so it's our least represented outcome among all the possible outcomes. And then just to brush up on our terminology again, if we're talking about trials, a trial would be a process that generates an outcome. So in this case, a trial, it would be drawing a crayon and seeing what color it is. So you can't tell, but my eyes are closed right now, and I'm drawing a crayon. The crayon I drew is green, so that's our outcome. The trial was sticking my hand in the pot and drawing a crayon, and then the outcome here would be green. I can do a second trial, and again, my eyes are closed, just take my word for it. Pull out another crayon, oh, and look, it's another green. So with that, you can now see how to calculate a probability, and then also think about another example of a trial being a process that can generate an outcome, and then the outcome being some characteristic that you are measuring here. So in this case, what we're measuring is the color of the crayon. And with that, I'm going to go back to the PowerPoint and talk about some rules for calculating probabilities.